Hello, Bonjour, it's Laura here. In this video, we're going to talk about the combined gas law. So basically what the combined gas law does is it takes all of the laws that we already know, the Boyle's, the Charles, and the Gay-Lussac, and combines that into one law. So this is the combined gas law here. So this is the pressure 1 times the volume 1. So this is the starting conditions. So that's the pressure 1 and the volume 1 divided by the temperature 1 equal the pressure 2, volume 2, temperature 2, and these are the ending conditions. So there's been a change in the middle, and we've had, so we start at something, there's a change, and then we end with different conditions. And so in this one, we can have two variables that are changing. Now, an important thing to note is that the moles or the grams, that's going to stay the same. So there'll be a change in two conditions. So say pressure and volume could both change, and then we would see how the temperature had changed as well. And the number of moles stays constant. So here's an example of a question that we could do. So as always, we want to fill in our chart of variables and then determine what the law is going to be. So we've got a sample of helium gas, and it has a volume of 0.180 liters. So this is the initial condition. So 0.180 liters. Okay, it starts at a pressure of 0.8 atmospheres. And it starts at a temperature of 29 degrees Celsius. Okay, and of course we can't use a temperature like that. We need to change it to Kelvin. So that's going to be 302 Kelvin. So that we've done that. Now at what temperature? Okay, so we don't know the temperature, and it needs to be in Celsius. Will the helium have a volume of 90 milliliters? So 90 milliliters here, and a pressure of 3.2 atmospheres. And the N is constant. All right, so we're dealing with 90 milliliters here and liters here. So let's convert the liters to milliliters because we need to have that in the same unit. So if I want to convert to milliliters, I'm going to move my decimal 3 points to the right, or I'm going to multiply by 1,000. Okay, so oops. So that gives me 180 milliliters. Okay. So we need to rearrange the formula to solve for our unknown variable. So our formula is P1V1 over T1 equals P2V2 over T2. So what variable are we looking for? So we're looking for T2. So what I can do is, same as before, even though we have more variables in this, we can use cross multiplication. So we'll multiply the variables that are diagonal from each other, and then divide by the leftover variables. So we'll divide by the P1V1. Okay, so that's what our formula will be. The temperature 1 times pressure ending times volume ending divided by the pressure 1 times the volume 1. Okay, so when we substitute the values in to solve for the unknown, notice here we've got the, this is our, like everything on the top. Notice units will cancel out. So the atmospheres will cancel out, the milliliters will cancel out, and what we're going to be left with is Kelvin. Okay, so 604 Kelvin. Now, the temperature asked for Celsius. It asked for the temperature in Celsius. So to get temperature in Celsius, you do the opposite. Before, if we start at Celsius, we add 273. To get Celsius, we're going to subtract 273. And when we do that, we get 331 degrees Celsius. Okay, so that's an example of how to solve a combined gas law problem. It's very similar to solving the Boyles-Charles, Gay-Lussac. Make your chart of values and then rearrange your equation and then substitute the numbers in and solve. Okay, so well done, miigwech.